Okay, and I'll try and give you time to do, that's what we're gonna be spending this period doing. Today is review day. Today is the last day of our term. The final, as you know, as it states over there, is this coming Tuesday, the 14th. Again, you will be able to access the final on Blackboard. It's going to be in a section that says final exam. You know how exams go on Blackboard. It's going to be a 30-question multiple choice test, and you have to answer all 30 questions. You have 2 hours to do it once you start. You can start anytime as early as 9:30 because that's when it's going to come out. You must start it at least by 12:30 because you have to be finished by 2:30. Again, those are the times that I am going to, that I will be available at my computer. Again, you don't sign into Zoom, you go directly to CUNY Blackboard, to your Math 136010 account on Blackboard, and you take your final exam on Blackboard. Again, if you have any problems with your computer, I don't say it happens often, but occasionally there are problems. If your internet goes down, your test will automatically be submitted. So if you're not ready to submit your test, you can email me. The only thing I have to tell you is that this is not like Delta Math. I can't just start you from where you left off. I can either restart you on a whole new test, or you have to just go with what you have already. My one option is I can restart. I can reset your test and you can start from the beginning. Let's just look at these 2 questions. This, as I said, this is review day. I'm trying to go back to the and I'm sort of trying to do it in the order in which we learned it in the term. One of the first things we learned about at the beginning of the term was what we call inequalities, how to solve an inequality. This happens to be what we call a double inequality. It's an inequality. It's where you have 2 inequalities in the same problem. It's also, I call it a double inequality, or it could be called a compound inequality. What we want to do with that is try and get the x alone in the middle. So we're going to focus on this middle section, and there's not too much there. It's just x minus 5. So we have to get rid of this minus 5. Now, that means the way we get rid of it is we add 5. Of course, if we add 5 in the middle, remember we're doing 2 things at once, we're adding 5 at both ends. And the -7 plus a 5 gives us -2. This stays less than or equal to, this is x because the 5 cancels out. And this is less than 4 plus 5, which is 9. And we get, this is our solution in inequality form. It's saying that -2 is less than or equal to x is less than or equal to 9. Or if we wanted to read it from the middle, it's 2 things it's telling us. It's telling us the x is greater than or equal to the -2, but at the same time, it's equal to 9. Now, we weren't asked to put this in on the number line, but let's see how it would look on the number line. Here's 0. Let's say this is my -2. Let's see, 2, 4, 6, 8, 10. Let's say this is this is 9. Since it says -2 is less than or equal to x, At -2, we're going to have to put in a filled-in circle. At the 9, it just says x is less than 9. That means an open circle at 9. And we fill in or join these. This is my solution written in on the number line, graphed on the number line. Now, what I was really asked to do was to put it in interval notation. If you want to recall what the interval notation is, you don't make the graph, you just put in the numbers. You always start with a number that's on the left, so this is going to be a -2. You put a comma on the right, you put your right number. And where there's a filled-in circle, you make a bracket, one of these square parentheses. And where there's an open circle, you make a regular parentheses. So this would be your answer in interval notation. Bracket -2, comma 9. Now, when you're looking at this on a multiple choice, you got to be very careful because those parentheses and those brackets look pretty similar. Make sure you know where you have a bracket and where you have a parentheses. Okay, let's look at this second one. This is what's called an absolute value equation. And what we have to do with solving an absolute value equation is first get the absolute value section all by itself. Isolate the absolute value, which means this +2, which is on the outside, has to come to the other side. So we subtract 2 from both sides. And therefore, we have the absolute value of 1/4 x minus 8, close the absolute value, is equal to 4 minus 2, which is 2. I take a pause here and look at this number that's on the other side. That number has to be a positive number. If there is a negative number here, it's impossible for an absolute value to be negative, so your answer would be no solution. Remember that circle with a line through it. No solution. But if it's positive or if it's equal to 0, then you can go further. So how do we go further? So whenever we have an absolute value equation, once we have the absolute value all by itself, we break it up into 2 equations. One equation is just with the absolute value sign dropped. 1/4 x minus 8 equaling 2. The second equation, you write the same exact thing, the 1/4 x minus 8, but in that case, you equal it to -2. You must get 2 answers with an absolute value equation. So we have 2 equations to solve. So first here, I'm going to add 8 to both sides, which will give me 1/4 x equaling 10. And since this is a 1/4, I'm going to get rid of the 1/4 by multiplying by the common denominator, which is 4/1. So 4/1 times 1/4 x will just give us 4/4 or 1x. And 4/1 times 10 will give us 40. Otherwise, you can just cross multiply. Multiply the denominator here, the 4, by the 10 here. The other one, we add again 8 to both sides. And I get 1/4 x equals -2 plus 8, which is 6. And again, I'm going to multiply by my common denominator of 4/1. Again, the 4/1 times the 1/4 just gives me 1, so that's 1x or x. And 4/1 times 6 is 24. So my 2 answers for this particular example, and we can write it like this, is 24 and 40. We can put it in these brackets, or you can just write it 24 and 40. But if you just give 40 or you just give 24 and you don't give both answers, it is not correct and you will get that problem wrong. And you must have in an absolute value equation 2 answers. Okay, does anybody have any questions about this? If not, I'm going to put another 2 examples on the board. I'll give you some time to work them out. While you're doing those examples, I'm going to take attendance. Again, this is review for the final. Here's the first one. Again, put this in interval notation. Suppose I gave you I want you to solve this. -5 times 5x plus 14 is less than -30x minus 40. That's one that I want you to do. And here's another one that I want you to do. Suppose I tell you that f of x is equal to x squared minus 5. See if you can find f of x minus 1 in simplest form. Okay, so I'm going to give you time to try these 2. Oh, thank you, Demiola. There's also, he's between 12 and 2, there is tutoring, and you can have your individual questions answered there. Okay, so I'm now going to take attendance. Again, I will be, if you are missing tests or homework, I will be sending you an email telling you that what you have to do or what you are missing. Again, if you're missing anything, it's going to affect your final grade. We've had a total of, aside from the midterm, and of course the final that's coming up, there have been a total of 5 tests, 3 on Delta Math and 2 on Blackboard. The one on Blackboard is you have until Monday the 13th to do that, and you're getting 2 chances to do it, and I will take the better mark as your mark. And of course, they're the final exam, that's 40 multiple choice questions, and the final exam is going to be 30 multiple choice questions. Jesus Antonio, Jesus Avila, Jackson Avila. Hi, Jackson. Tiffany. Kayla. Tashana. Hi, Tashana. Dion Carter. Wensley Charlemagne. Tatiana Collins. Awa Diallo. Hi, Awa. Ashay Douglas. Hi, Ashay. And Tatiana, I saw. I see that you got on also, Tatiana. Let's see. Eliana Estee. Emily Gomez. Anastasia Guerra. Zenabu. Zenabu Hamed. Ismail.
Here,
Hi, how are you?
good. So for the final, could we start it at 2:30?
No, you have to be finished by 2:30. Is that a problem for you? It's next Tuesday.
I would rather like start it at 2:30.
Actually, I was told to start at 9:30 and finish at 11:30. When you, if you have a conflict, I can give it to you at a different time. But if it's just a matter of, I'd rather do it later, I really can't do that for you.
How long is it?
2 hours,
2 hours once we start?
yes.
All right.
How early can you start?
I could start at 1.
Okay, then you know what, I'm gonna change this and I'll make it available until 3 p.m.
All right, that's good.
I'll make it available for everybody until 3 p.m. But that really means the very latest you can start is 3 p.m. It is 1 p.m. Okay, so let's, when I set it up, I'll set it up. And I will periodically, obviously I'm not sitting at my computer every single moment, but I will be checking my emails every 15 or 10 or 20 minutes and making sure if there are any problems, I will be available till 3 o'clock. Okay, but again, you must start by 1. Jaden Jackson.
Here.
Hi, Jaden.
Hey.
Ashiana Jacobs. Hi. Anijah John. Thomas John.
Good.
Hi. Paul LeBrun.
Good morning.
Good morning. Ashley Murhead. Angelica. Tayon. Hakeem. Oh, hi, I see. Tayon, hi, and Hakeem, hi. Craig Ricketts. Devonly St. Jules. Devonly. Najee Waddell. Okay. I see Tashana has already given us 2 answers. So let's see if we can do these 2 problems. All right, first of all, this is also an inequality. This is not a compound, it's not a double inequality, it's just a single inequality. And we solve it very much like a regular equation. We remove our parentheses. So we have negative 25x, because we're removing, we're using distributive property, and negative 5 times 14 is negative 70, is less than negative 30x minus 40. If you recall, when you have a single inequality, you always want to end up with your x's on the left side and your regular numbers, your constants, on the right side. So I'm going to add 30x to both sides. Which will give me negative 25x plus 30x will give me 5x. And minus 70 less than negative 40. And then we're going to bring this 70, this negative 70, the other side by adding 70 to both sides. So that we end up now with 5x less than negative 40 plus 70 is 30. Notice in each case, I have kept the, what we call the sense of the inequality, the direction of the inequality the same. Okay, let's go over here. So if I have 5x less than 30, I'm going to divide both sides by 5 to get the x alone. And that'll give me x less than 6. Remember, if this number that you're dividing by, if the number in front of the x is a negative number, you divide by a negative number, that's when you change the direction of the inequality. We divided by a positive number, so we left this in a less than. But if this would have been a negative 5x, then, and I had to divide it by the negative 5, I would have had to switch the direction of the inequality. This is the answer in, not in interval notation, as an inequality. In interval, this, what it looks like on the number line is this. Here's my 0, 1, 2, 3, 4, 5, 6 is over here. And it's an open circle at 6, because this is just a plain less than. And since this is pointing to the left, we have our arrow going to the left. In interval notation, that would look like, remember when you're writing the interval, you start on the left side and you work to the right. All the way to the left means negative infinity. And all the way to the right, where we stop here, when we stop, we're stopping at 6. Now, wherever we use that infinity symbol, we always use a parentheses. You never use a bracket with infinity. You always use a parentheses. But with the regular numbers, sometimes you use the brackets and sometimes you use the parentheses. Since this is an open circle, it means that 6 is not included. It's called an open interval. We're going to use a parentheses. And this would be your answer in interval notation. This one, number 2, is we're told that f of x equals x squared minus 5. We're using interval notation. And when we want to find f of x minus 1, what that's telling me to do is to wherever I see my x over here, which is right here, in that I'm going to replace that x with an x minus 1. In other words, this is going to be, here's my x. Well, I'm not calling it x anymore, I'm calling it x minus 1. It's going to be x minus 1 squared. Because, in other words, I take this x out, leave it as a parentheses, and fill it in with whatever is over here. If this would have been 10, I would have been done 10 squared. Since it's x minus 1, we're doing x minus 1 squared and minus 5. Now, there's nothing wrong with leaving an answer like this, but I said to simplify it, which means we have to get rid of the parentheses. We first have to do x minus 1 times x minus 1. In other words, squaring means using FOIL. Don't forget, when you square a binomial, you use FOIL. So x times x is x squared. Outer is negative 1x. Inner is also negative 1x. And last is negative 1 times negative 1, which is plus 1. Otherwise, we could have remembered how to do the quick multiplication. And of course, then we have this negative 5. And combining the like terms, we have x squared, negative 1x and negative 1x is negative 2x. And plus 1 minus 5 is negative 4. And this is the answer that you should have come up with for what f of x minus 1 is equal to. So remember how to do functional, it's called functional notation. Shauna, that was excellent. Okay. So going on with our review, I'm going to erase these two, and I'm going to put 2 more problems on, give you some time to try them, and then we'll go over them. Just as a reminder, this is a word problem. A construction, I'm gonna not write all down, I'm just gonna write the important information. We have a construction company that wants to build a swimming pool, and the perimeter of that swimming pool is 58 meters. The length is 11 meters more than the width. I want you to find the dimensions. That's one question. Here's another question I'd like you to do. This is writing the equation of a line. I want you to write the equation of the line that is perpendicular to negative 3x minus y equals 4, and passes through the point 0, -7. Want you to write that equation. Okay, I'm giving you a few minutes to try this. Okay, I think, let's try these now. Okay, we have this pool whose perimeter, let's just draw a little picture of it. It's a rectangle, and perimeter means everything all around. The perimeter is 58. We're also told that the length is 11 meters more than the width. So if I call my width x, 11 more means x plus 11. The length is x plus 11. Now in a rectangle, the opposite sides are equal. So this will also be x, and this will be x plus 11. And the perimeter of any figure consists of all the sides added. So if we add up all the sides, x plus 11 plus x plus x plus 11, we're going to get 1, 2, 3, 4x. 11 and 11 is 22. That's going to be my perimeter, and we know how much the perimeter is. It's 58. So here's my equation. Just remember, when something says 11 more, it means add 11. If this would have said 11 less, we would have done x minus 11. Whatever if it's more, you're adding it at the end. If it's less, you're subtracting it at the end. Okay, and now let's just solve this. I'll subtract 22 from both sides. This will give me 4x equals 36. And when I divide by 4, gives me x equal to 9. So it turns out the width, which is the x, is equal to 9. And the length, which is x plus 11, is 9 plus 11 is 20. So my dimensions are 9 by 20, or you can say the width is 9 and the length is 20. Okay, so that takes care of basically chapter 1. Those 3 problems were from chapter 1. Let's go on to this problem, where we're told the equation of a line. We want to write the equation of a line. The line is going to be perpendicular to the line negative 3x minus y equals 4. And it's going to go through the point 0, negative 7. Let's go over here. First of all, let's remember, when we talk about perpendicular and parallel, what it's giving us is information about the slope of the lines. 2 lines that are parallel have the same slope. Their slopes are exactly the same number. 2 lines that are perpendicular have negative reciprocal, or if you want to call it opposite reciprocal slopes. So I'm going to start with my original line, which is negative 3x minus y equaling 4. And I'm going to put that into the y equals mx plus b form. I'm going to solve for y. So I'm going to get this 3x to the other side, which will give me negative y equals 3x plus 4. And since I don't want to know what negative y is, I want to know what y is, I'm going to divide everything by negative 1. So in slope intersect form, the original line that we had is y equals negative 3x minus 4. Okay, now I'm going to go up here. I'm going to erase this. Just need board space. Okay, so we have, this is my original line. Y equals negative 3x minus 4 in y equals mx plus b form. So that's the first thing we have to do. We see the slope of this line then is the number in front of the x, the coefficient of the x, which is negative 3. So for my perpendicular line, the slope is going to be the opposite reciprocal. I'm going to have to flip this number over, and I'm going to have to switch its signs. So this is really a -3/1, so I'm going to get 1 over +3. I'm going to flip the number over and switch its sign. So my new equation is going to be y equals 1/3 x plus b. And now we want to work on what is the b. We have the slope. We still have to figure out what the y-intercept is. So that's where the fact that it goes through the point 0, -7 is. Now, there are two ways of going about it. The normal way to do it is just replace the x with 0 and the y by -7. If I do that, -7 equals 1/3 times 0 plus b. And of course, 1/3 times 0 is just 0. Anything times 0 is 0. So this gives me b equals -7. You might have noticed right away because 0 minus 7 is on the y-axis. In other words, 0, -7 is the y-intercept. And that's what b stands for. So my final answer comes out to be y equals 1/3 x minus 7. That would be the answer. Remember, when lines are parallel, the slopes are the same. When they're perpendicular, they're opposite reciprocals. Also remember vertical lines, lines that go straight up and down, just have an equation with an x in it. X equals a number. And the slope of a vertical line does not exist. It is, there's no such thing as the slope of a vertical line. It is, and if we have a horizontal line that goes straight across, then we have an equation which just has a y in it. Y equals a number, and the slope of that line is 0. So vertical lines have slopes that are, sometimes we use the term undefined. Horizontal lines have slopes that are equal to 0. Okay, so that's pretty much a quick review of graphing of linear equations. So now let's talk about systems of equations. Oh, let's do a couple of questions that have to do with systems of equations. Okay. First of all, solve this system of equations. X minus 3y equals 15, and 7x minus 2y equals 10. That's one question. And here's a word problem that we can use a system of equations for. So we have tickets to a school play cost $5 each for students and $8 for adults. So we know how much they're charging for each kind of tickets. A total of 360 tickets were sold. And the amount of money they made from this, selling these 360 tickets was $2,640. And we want to know how many student tickets were sold and how many adult tickets were sold. Okay, so I'm going to give you again a few minutes to try these problems out. Okay, let's do this topic example. The way this is set up, where you have the X's, the Y's, the equal signs, and the numbers all lining up, which is called the standard form, sets us up for what we call the addition or elimination method. We decide which variable we're going to eliminate. I'm just, let me see. Deshauna already got an answer. I'm gonna get rid of the Y's just because I decided I want to get rid of the Y's. It doesn't matter. Now, if you remember what you do, you multiply each equation by the opposite coefficient. We're looking at the Y's, so the top equation here, I'm going to multiply by 2. And the bottom equation, I'm going to multiply by 3. Now, I know both of these have minuses in front of them, but the first thing I look at is just the numbers. So this one, I'm going to multiply by 2. This one, I'm going to multiply by 3. Then I think, these are both negatives, but in order to eliminate, we need one to be positive and one to be negative. So I'm going to use a negative with one of these. It doesn't matter which one. So if I use a negative with the bottom equation, my top equation becomes 2x minus 6y equals 30, multiplying everything by the 2. The bottom equation becomes negative 21x. Negative 3 times negative 2 is plus 6y equals negative 30. Again, I see that this is going to work because if I want to get rid of the y's, I need them to have the same coefficient, but one being minus and one being plus. So now I just add these down, negative 2x plus negative 21, positive 2x, and negative 21x gives me negative 19x. The negative 6y and the positive 6y cancel out. And on the other side, I have 30 plus negative 30, which gives me 0. And I'll just divide both sides by negative 19. And then 0 divided by negative 19, of course, is 0. So it turns out that my x turns out to be 0. Now, when I'm solving a system of equation, it can't be just the x value. I have to have the y value as well. So I go to either one of the original equations. Let's say take the first one. I'll replace the x with 0, and I'll get 0 minus 3y equals 15. So that's just negative 3y equals 15, because 0 minus 3y is, the 0 just drops out. And I divide by negative 3, and it gives me y equals 15 divided by negative 3, which is negative 5. So my solution to that equation is x is 0, y is negative 5. Okay, now let's look at this second one. Here, we have another word problem. It's a very common type of word problem where we have two types of items. In this case, the two types of items we have are two types of tickets. There are student tickets. So let's call the number of student tickets let's call that our x, and let's call the number of adult tickets y. You really have to set in your mind or write down what your variables represent, and you be as specific as you can. Don't just say, oh, X stands for the student tickets, because there are many things that could have to do with student tickets. What the X stands for is how many student tickets were sold. And the Y stands for how many adult tickets were sold. Now, we know that a total of 360 tickets were sold. So that equation becomes X plus Y equals 360. It has nothing to do with money, it's just how many there were. So there were adult tickets and student tickets together, they were 360 of them. Next, we have to think about how much money was made. Now, how do we make money? For each student tickets, we got $5. So the total amount of money from the student tickets was 5 times X. And the total amount of money from the adult tickets was 8Y, because each adult ticket was $8. So if we take the 5X plus the 8Y, that'll give us a total amount of money that was earned at this play. So now our second equation became 5X plus 8Y equals 2640. Again, we want to solve this. Let's do it by, let's get rid of the X's now, which means I'm going to multiply this by 5 and this by 1. But again, they're both positive, and we need one to be positive and one to be negative. So we have to use a negative with one of them. I'm using it with the first one. So the top equation becomes negative 5X minus 5Y equals, okay, where's my calculator? I'm going to let my calculator do some work for me. Negative 5 times 360 is negative 1800. And since the bottom equation is just being multiplied by 1, it stays 5X plus 8Y equals 2640. Okay, so when we add the negative 5X plus the 5X cancel, the negative 5Y plus the 8Y gives us positive 3Y, and the negative 1800 plus the 2640, and again, I'm doing this on my calculator, gives me $840. Only 800. And now I'll divide both sides by 3. And that'll give me that Y is 280. 280 adult tickets were sold. How many student tickets were sold? Well, we know that the X plus the Y, which is 280, had to equal 360. I'm just replacing the X over here, the Y over here with 280. And if I subtract 280, I get that my X is 80. So that 80 student tickets were sold and 280 adult tickets were sold. And that's pretty much takes care of the chapter on systems of equations. So let's do some more problems. Okay, let's do some factoring of polynomials. Let's see if you can factor these. Okay, factor that and factor this one. Okay, see if you can factor both of these.
Professor, that's a minus 18 or a plus 18 for the second one.
Okay, I see that some of these questions have been done. So let's do them together. First of all, we want to factor 25x squared minus 16. Remember, the first thing we always look for when we go to factor is, do we have a common factor? And there isn't. There's no number or letter that goes into both terms. We see that we only have two terms, so if there's no common factor, the other thing we look for is what's called the difference of squares. This is a perfect square, this is a perfect square, and we have a minus in between them. So therefore, we can factor this into two parentheses, 5x plus 4 and 5x minus 4. You just have to see the pattern. Again, it wouldn't be different if the minus would have been here and the plus here, but there has to be one with a plus and one with a minus. They are what are called conjugate binomials. They look exactly the same except for the signs in between them. This one to factor, when we have four terms, again, we look for a common factor of everything, and there isn't. Even though 2 goes into here, it doesn't go into here. There's no common factor, so we try and do what's called the grouping method. We look at the first group of numbers, the 2a cubed minus 4x squared, and find a common factor of those two terms. And obviously it's a 2, and this is an a cubed and a squared, so there's a common factor of a squared. And 2a squared into 2a cubed is a, and 2a squared into 4a squared is plus 2. The a squares cancel out. Then we go to our next group and look for a common factor there, and I see a common factor of 9. So that becomes 9 times a, and 9 to 18 is 2. And we see in both of the parentheses are the same. So we have a common binomial factor of a plus 2. We put the a plus 2 in front. And in the second parenthesis, we put the 2a squared plus 9. Again, it doesn't matter which you put first and which parenthesis goes first and which goes second. If you wrote 2a squared plus 9 first and a plus 2 second, that would be perfectly correct as well. All right. So now let's see what other type of questions we might have. We're going on to chapter 5. So first of all, let's remember how to divide a polynomial by a polynomial. I'm just going to give one example now because this is going to take a lot of space. So what if I wanted to divide 3x cubed minus x squared plus 2x plus 6. I want to divide that by, this is a division problem, it's not a factoring problem, x plus 1. Give you a couple minutes to try it, and then we're going to do it together. Okay, let's do this together. We're sort of running out of time, so I want to just do this problem, and then I'm not going to have time to do all the different types of problems, but I do want to do a problem that involves odds, whatever. Let's do at least this problem. If you remember what we do when we have a division, a polynomial by a polynomial, we just set it up like a long division. So we put the x plus 1 on the outside. And on the inside, we do the 3x to the third minus x squared plus 2x plus 6. Remembering that the terms have to be in what we call descending order. And if any term is missing, like if there wouldn't have been an x squared term, I would have had to put a 0x squared. I had to account for every term. And then what I do is I take my first term in my divisor, which is the x, and divide it into the first term of the dividend. So x into 3x cubed gives us 3x squared. And you put that on top. And then you do 3x squared times x, which is 3x cubed, and 3x squared times 1, which is 3x squared. So divide, now we multiply, now we subtract. We're going to subtract what we just put down from the original. Remembering, when we're doing subtractions, we first want to change the sign. So this is going to become a negative, and this is also going to become a negative. And we'll get 3x cubed minus 3x cubed, which cancels out. And over here, we'll have negative x squared minus 3x squared, which together gives us negative 4x squared. After we subtract, we bring the next term down, which is the 2x. And start the process again. I divide the x, the first term, into the first term, the negative 4x. So negative 4x squared. So x into negative 4x squared gives us negative 4x. I put that on top, and then I multiply by it. So negative 4x times x is negative 4x squared. And negative 4x times 1 is negative 4x. And again, I want to subtract, so I'm going to change my signs. So this is going to become a plus, and this is also going to become a plus. And negative 4x squared and positive 4x squared cancel. And here I have 2x plus 4x, which gives me 6x. And I bring down the next number, which is 6. And I start again. The x into the 6x. Well, the x's cancels out, and all I'm left with is the 6. I put plus 6 on top. 6 times x is 6x. 6 times 1 is 6. Again, I change my sign so I can subtract. This cancels out. This also cancels out. There's no remainder, so my answer comes out to be 3x squared minus 4x plus 6. If there would have been a remainder, we often take that remainder and put it over the divisor. That. Okay. Are you okay with it now, Tashana?
Yes, Professor, I'm working through it again.
Okay, great. Okay, let's do one more problem. Let me see what don't forget, you have to know how to work with radicals. You have to know how to, don't forget there's still the graphing of the, we talked about graphing of quadratic equations, circles, parabolas, ellipses, and hyperbolas. What about a question like this? And don't forget, you must know how to solve a quadratic equation using the quadratic formula. That's very important. So let's do this example. X squared equals -5 minus 2x. Let's see if you can solve that quadratic equation. Okay, let's do this together. And remember, this is a quadratic equation that we want to solve. And when we want to solve quadratic equations, we try to get it equal to 0. So I'm going to add 5 to both sides. And I'm going to add 2x to both sides. So that I end up with x squared plus 2x plus 5 equals 0. Now, usually we try factoring this, but if you notice, this can't be factored because the AC is 5. We need two numbers that multiply to 5 and add to 2. And I can't fit any numbers. So we're going to solve this. This one you could either solve using completing the square or the quadratic formula. Just as a reminder, the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. And our a in this case is 1, our b is +2, and our c is 5. So I'm going to get -2, it's -b, plus or minus the square root of the 2 squared, that's the b squared, minus 4 times 1, my a is 1, times 5, and it's all over 2 times 1. And figuring out what's inside this radical is the most important thing to do. 2 squared is +4, -4 times 1 times 5 is -20, and 4 minus 20 gives us -16. So this becomes -2 plus or minus the square root of -16 over 2 times 1, which is 2. Now remember, the square root of -16 is the square root of 16 and the square root of -1, which is 4i. The square, don't forget, you have to know how to work with those square roots of -1s. Those are our i's. So this ends up being -2 plus or minus 4i over 2. And we can divide the 2 into both terms. So -2 divided by 2 is -1, plus or minus 4i divided by 2 is 2i. And here's our answer, -1 plus 2i and -1 minus 2i. Excellent, okay. So I think that's it for today. Don't forget to go back and make sure you have all the material and work completed so that you can get as much credit for this term as possible. Again, I'll repeat this. The final exam is worth 35 points. The midterm is worth 25 points. That's 60 points altogether. The homework is worth 10 points. And the tests and quizzes together is worth another 30 points. I usually give 15 points for each, but usually I just put them all together. Now, the homeworks, it doesn't matter what mark you got. If you did 16, there were 19 Delta Math homeworks assigned. If you did 16 or more, you get full credit for the homework. Otherwise, your mark will be, if you did 8, you get only 5 points instead of the 10 points. Also, there is a total of, there were 3 Delta Math tests and 2 tests on Blackboard. Those will be averaged up for your other mark. And those all totaled will give you your final mark for the term. So make sure you have everything done for the term. Good luck on the final and good luck next term. Hopefully everybody will stay well. And it was a pleasure teaching you. Again, if you're missing, I will be going through my records and checking. If I see anything is missing, I will email you saying you are missing whatever you're missing. Have a nice weekend. Don't forget, Tuesday, you can start as early as 9:30, but you must be completed with the test by 3 p.m. on Tuesday. If you can't do it at that time, if you have a conflict, then you have to let me know. Okay? Have a good weekend. Thank you. Thank you for being such good. The students that came today were my good students who usually showed up. Thanks. It was a pleasure having you.